Parent doesn't give its chicks their food immediately. The chick is gulping. The parent bird is producing liquid from its stomach and letting it trickle down its beak. Each youngster gets its share. Another ration of solid food, this time a lizard. And each time, before the meal is handed over, the chicks get a drink, whether they like it or not. During the heat of the day, the parents sit on the nest not to keep the chicks warm, but on the contrary, to keep them cool, by shading them. And the sitting bird not only flutters its throat, but protects itself from the sun by using its tail as a parasol. The ground squirrel of the Namib Desert in southern Africa does the same thing, and very effectively too, carefully angling itself as far as possible to keep its body in the shade. Many animals keep their blood cool with radiators. The hedgehog that lives in the desert of the Middle East has unusually large ears. Blood circulates through capillaries close to the surface of the skin and is cooled by the breeze. The fennec fox's huge ears serve the same purpose. And so do those of the American jackrabbit, which perhaps has the biggest ears of all in proportion to its body. The Dorcas gazelle also has radiator ears and is one of the best adapted of all desert mammals. It's one of the very few that can survive without a drink at all. It gets all the liquid it needs from the vegetation. It doesn't waste liquid as urine, but gets rid of its uric acid as small dry pellets. It's now approaching noon, the hottest time of the day. It's summer, the hottest time of the year, and I'm in one of the hottest places on Earth, Death Valley in the western United States. A thermometer on the ground here has risen to 201 degrees Fahrenheit. That's about 94 degrees centigrade. It's so hot that no creature can survive permanently out here. Even at the edge of these sand flats, where the ground is a little more broken, there is no sign of animal life whatever. All animals now have sought the shade and shelter from this ferocious sun. But there are some organisms that can't get out of the sun. Plants, being fixed to the ground, have to stay out in the heat of the day and simply endure. But all of them have special devices to help them to do so. The desert holly, its leaves grow at about 70 degrees to the vertical, so that in the morning when it's less hot and in the evening, and the plant needs light, it presents the face of its leaves to the light, but during the middle of the day it shows only the edges, and so it doesn't heat up so much. Not only that, but the plant extracts salt from the salt-laden ground and excretes it as a white coating on the surface of the leaf, which, like the white costume of an athlete, reflects the heat and so keeps the plant that much cooler. And this, the creosote bush, this is one of the most widespread of plants in American deserts. and its roots are better at extracting the last molecule of water from these parched sand than those of any other American plant. And this has led to a most extraordinary state of affairs that's only just been discovered. It seems that the creosote bush was the first plant to establish itself in the arid sand of the Mojave Desert when the desert first appeared. And once it had established its extensive root system, it extracted moisture from the sand so efficiently that it was extremely difficult for any other plant to grow alongside it. And that applied not only to any other kind of plant, but also to its own seedlings. So an individual creosote bush tended to spread not by setting seeds and producing a new generation, but by sending out new stems around its base. And as these spread outwards, so the stems in the middle tended to die away, and the bush grew into a ring shape like this. So these are not separate individual creosote bushes as it might appear, but this is just one big ring-shaped individual plant. Over the centuries, the rings widened and changed their shape until now some are over 25 yards across, like this one. Of course, the individual stems and leaves of this plant are not very ancient. The first ones to grow that appeared in the middle have decayed and disappeared a long time ago. But now it's estimated that this plant started growing between 10 and 12,000 years ago. In fact, when the Mojave Desert first appeared. And that makes it the oldest known living organism in the world. In the Mojave, the plants may have to survive for as long as 10 years without rain. But if rain falls just a little more frequently, as it does nearby in Arizona, plants can have different survival strategies. To many of us, the very symbol of the desert is the cactus. But in fact, this family of fleshy-stemmed plants lives only in the Americas. There are several hundred species of them, but among the biggest is the saguaro. The saguaro has solved the problems of surviving in great heat and drought very successfully indeed. Its stem is pleated like an accordion, so that when rain does fall, the cactus can expand and quickly absorb as much of the water as possible before it disappears. After a single storm, a saguaro can take up as much as a ton in a few days. Its leaves have become thorns, so reducing the surface area from which the plant might lose water by evaporation. The stem itself is green and has taken over the job of photosynthesis. The thorns protect the young plant from browsers, but they also break up the wind currents, so that the cactus is wrapped, as it were, in still air, and evaporation of moisture from the stem is kept very low. These huge saguaro cacti can live for over 200 years and stand nearly 50 feet high. A big one like this may weigh as much as 8 tons, and 90% of that is water. If I was dying of thirst in this desert, I'd be tempted to cut inside that saguaro and raid its reservoir of water. But that would probably be a mistake, because the water in the saguaro contains a poison. But there are lots of desert-living plants which do have drinkable water within them. And desert-living people all over the world have become expert botanists, able to recognize from just the tiniest little leaflet or straggling stem where they can get a good drink. None are more skilled than the Bushman people of the Kalahari. By the end of the dry season, all their water holes have usually dried up. For liquid, they must now rely almost entirely on plants and their ability to recognize the right ones. This tuber is a kind that provides good drinking water. This much larger one is also full of liquid, but unfortunately it's so bitter it's undrinkable. But it's worth having nonetheless. To extract the water, the root must be grated and pulped. The bigger root is grated as well. Drier though it is, it still contains valuable fluid. Since it cannot be drunk, the people use it to moisten their skin, and as it evaporates, it brings a delicious, refreshing coolness. "200 miles to the west of the Kalahari lies an even hotter, drier desert, the Namib. Very few plants indeed can survive in these parched sands. Patches of grass sprouted after a rare shower of rain and lived for a few weeks, but that was over 4 years ago, and now only the dusty, withered stems are left. There is one plant that grows here, though, and indeed nowhere else, and one that is very odd indeed." The scientist who first described this extraordinary plant was an Austrian called Dr. Welwitsch, who came to this part of Africa in the middle of the last century. He discovered many plants in Africa, but this perhaps is his most famous, and the one that bears his name, being called Welwitschia. There are male plants and female plants. This one is a female, and these are the female structures. These are young ones which sprouted this year, and these are the fully developed ones from last year. In structure, they're very like the cones of a fir tree. The male plant has growths rather like stamens which produce pollen. So Welwitschia seems to be a kind of link between coniferous trees and true flowering plants. But the oddest thing about it, perhaps, are its leaves. They grow from the top of its central trunk, and what's more, do so extremely slowly, so that this length of leaf would have taken about 70 years to be produced. But if it hadn't frayed at the edges, it would be about 400 yards long, because this individual plant is thought to be about 1,500 years old. It's these amazing leaves that enable the plant to collect water in this rainless country. The Namib lies close to the western coast of Africa. At dawn, fogs regularly roll in from the Atlantic. As they swirl around the Welwitschia, their moisture condenses on the plant's huge leaves. Some droplets are absorbed through cracks in the leaves' skin. The rest of the water is channeled down to the ground, where it's sucked up by roots just below the surface of the sand. The fog also provides life-saving drinks for some of the desert animals. These are darkling beetles. On foggy mornings, they climb to the top of the dunes and stand in lines, head down, abdomen up, slowly marking time. Droplets of water from the fog collect on legs and antennae, and then, as the beetle lifts its feet, trickle down towards its mouth. The Namib's fogs never penetrate very far inland. Those deserts that lie a long way from the sea, therefore, can never receive moisture in such a way. Their water must come from the clouds. Only too often the clouds that do build up above a desert sail off elsewhere without bursting, and the land remains parched. But when eventually rain does come, it's the trigger for immediate and urgent action. One or two drops are all that's necessary to activate these dead stems. Within half a minute, they're upright. Other plants begin to open their seed heads. None of these plants is alive. All their movements are simply the result of the dead tissues absorbing water. The dead seed heads have held the seeds securely during the drought. Now, since there's been rain and there's a chance of them germinating, they can be distributed. For some plants, the heavy raindrops are enough to dislodge the seeds. Others utilize the physical effects of absorbing water to shoot the seeds away. Now the seeds themselves, lying on the ground, begin to move. As the hairs absorb water, they swell and stiffen, so raising the seed into the right position for its first rootlets to strike straight downwards into the ground. But sometimes in the Arizona desert, maybe once in several years, there are real cloudbursts and the desert is transformed. In the aftermath of the flood, new faces appear. A spadefoot toad. The males are the first to emerge from the soil where they've been buried for the past year or more. Hastily, they make their way down to one of the temporary pools that have appeared in the desert, and there they begin calling, summoning the females. There is great urgency. If they don't mate on this night, they may have lost their chance. Within 24 hours, the eggs have been laid and fertilized and are beginning to hatch. A day later, and the pool is full of tadpoles. Other creatures have appeared as if from nowhere. Fairy shrimp have hatched from tiny eggs blown with the dust all over the desert. The tadpoles are growing fast. These, with small mouths, feed on algae and bacteria, a diet usually abundant in these desert pools. But other individuals that hatch from the same batch of eggs develop bigger heads and more powerfully muscled jaws. They have become meat eaters. Not all pools will provide enough food for them, but here they're fortunate. They even eat their vegetarian brothers. With such a protein-rich diet, they grow even faster than the algal feeders. Here they are the favoured few, more likely to survive if the pool evaporates very quickly indeed. They're an insurance for the continuation of the species, for which the payments are their vegetarian brothers. But now the pool is shrinking fast. Another couple of days and it's almost gone. Unless there's another shower of rain, all the tadpoles will die. If they do die, their bodies will not be wasted. They will decompose and fertilize the sand, so ensuring that when the next rains come and another pool collects in this particular hollow, the algae will grow fast and well. Ants are quick to attack these stricken tadpoles. But at the last minute there is a reprieve, a short shower of rain. Some of the tadpoles, even though they still have a tail, do now have legs, and they're able to leave the puddle just 2 weeks after hatching. Even among this tiny proportion of survivors, the mortality will be huge. But with luck, a few will join the adults as the desert dries and bury themselves to wait for the next shower of rain many months from now. For several weeks after the rains, the desert blooms. The seeds, shed by the shriveled plants, had sprouted and burst into flower. And so deserts after rain all over the world, in Arizona and Australia, the Namib and the Sahara, put on one of the most dazzling displays of colour that you can see anywhere. Deserts are shaped by the sun and the wind. The roasting of the rocks during the day, their chilling during the cold nights, eventually makes their surface crumble. Some of their minerals splinter and fray into dust, but quartz, the commonest, is very hard, and that remains as grains of sand. The wind catches them, sweeps them away, and collects them together as sand dunes. Dunes may be hundreds of feet high. If the wind is more or less constant, it blows the grains up the gently sloping side and over the steep front, so that the dune marches slowly across the desert. Trudging up the face of a dune like this is extremely hard work. The sand is so dry and the grains are so polished by the wind rubbing them together that the surface is continuously on the move, and it's quite impossible to get any firm foothold. And of course that problem faces not just me, but all the animals that live among these dunes. And some of them have developed some extremely ingenious solutions to the difficulty. These extraordinary tracks have been made by one of the swiftest movers across the dunes. The sidewinder, a kind of rattlesnake. It skims across the surface by throwing its body into a series of loops which only touch the sand at 2 points. This not only enables it to move very fast, but keeps most of its body off the hot surface. In the middle of the day, the sand is so hot that it's painful to touch. The Namib fringe-toed lizard prevents its feet from scorching by gymnastics. But eventually it gets so hot, the only thing to do is to shelter beneath the surface where the sand is very cool. But burrowing through this kind of sand also has its problems. An animal can't construct a tunnel like a mouse hole or a rabbit burrow because the sand is so smooth it simply falls in behind it. So instead it has to wriggle through the sand almost as though it's swimming. And that's precisely what this little creature does. It may look like a worm, but in fact it's a lizard that has lost its legs. And you can see that it's a lizard when you look closely at its face. For it has a mouth and 2 eyes covered by transparent scales that protect them in the sand. It's a blind skink. It lives by hunting for insects below the sand surface, and when I put it down, it'll wriggle away just like an eel. The most extremely specialized of these hunters in the dunes is not perhaps a reptile, but a mammal. It's very rarely seen, and your best chance of finding it is at night. These are its tracks, and that depression, a place where it caught something. And this is where it has burrowed again, and where, with luck, and if I dig very fast, I might catch it. Here it is, a golden mole. This one is a baby, but like its parents, it's totally blind. Eyes are of no use beneath the sand, nor are ears, and it hasn't got those either. Its head ends in a kind of leathery wedge with which it pushes its way through the sand, or alternatively through my fingers. Golden moles will eat quite large creatures, a blind skink if it encounters one within the dune, or other creatures that might be wandering unsuspectingly across the surface. A cricket would do nicely. The great sandy deserts of the world, in Arabia, Central Australia and the Sahara, have repelled even the hardiest of human travellers. Few people have managed to survive in them for long, totally unaided. But some manage to make regular journeys through these wildernesses. These are the Tuareg. They travel from one side of the Sahara to the other, carrying great cakes of salt, which they trade for cloth and grain and dates. But even the Tuareg can only make these journeys with the help of an animal desert specialist, the camel. They have to take all the food that they and their camels will need with them. Water is carried in skins slung beneath the camels' bellies to minimize evaporation and keep it as cool as possible. The camel itself is marvelously adapted to life in the desert. Its toes are reduced to 2, but they're connected by skin so that they splay out on the sand and don't sink deeply into it. Their nostrils are closable, so they can shut out sand grains during a sandstorm. The hair on their body is restricted to the top, where it serves as a shield against the sun, but elsewhere, for coolness, their skin is virtually naked. Their hump is full of fat, which, in emergencies, can be converted to water. But the process wastes a lot of the fat's calories, and the camel only does it when it hasn't drunk for a very long time. It can, in fact, live without liquid water for 4 times as long as a donkey and 10 times as long as a man. But eventually, even a camel has to drink. At 1 or 2 places in the Sahara, water can be reached by digging deep into the ground. Here, camels can at last refill their stomachs, and they take a lot of filling. But if the Tuareg can't cross the Sahara without the camel can't do so without the Tuareg, for only men can dig wells and haul up the essential water. Spring water is the key which unlocks abundant fertility. At Saharan oases like this one, all kinds of crops can be produced from the sand if it's watered. Dates and vegetables and fruit. Insects whiz and buzz over the gurgling irrigation channels, and birds sing in the palm trees. But these small islands of life are under constant threat. If the wind veers and blows steadily from another direction, nothing can stop the sand. Eventually, the advancing dunes may well overwhelm this oasis, and then this small world that's been brought into existence in the middle of the desert by the presence of water will be extinguished. The force that drives the dune, of course, is the wind. And the wind, too, has its own world of living organisms. Many of the spiders and beetles and other insects that live in the oasis here will have arrived by air, and many of the plants, too, coming either as wind-blown seeds or carried on the feet of birds. And that world, the world of the wind and the sky, we'll be exploring next time.